Hello students, welcome you all again in the next part of our chapter, Natural Resources. In this part we will study the biogeochemical cycles. Now what are biogeochemical cycles? These are substance turnover or cycling of substance in a pathway by which a chemical substance moves through both biotic, abiotic components of earth. These cycles they ensure that the matter is transferred and also the energy between the biotic and abiotic components of earth, of our nature. Now some important cycles are water, nitrogen, carbon and oxygen cycle. Now first is water cycle. You all have studied this in previous classes. Now this cycle is also called hydrological cycle or hydrologic cycle, and it describes the continuous movement of water on, above and below the surface of earth. Now what happens in this are water bodies. They are heated during day, produces vapors. The vapors are added by a process like respiration, by guttation, by various factories, by evaporation from water bodies, and they rise upwards and condense to form small water droplets. These droplets they act as seed. They combine together, merge to form clouds. These clouds they move with the wind, and depending on geography, whenever they encounter an obstruction, they cause rainfall. Now some of these water enters the ground and form groundwater, whereas some stays at surface in rivers, lakes and ponds and form surface water. Now this is a typical water cycle in which you can see various processes involved in it, like condensation, evaporation, transpiration, infiltration of water through soil layers to reach the groundwater, there is precipitation, etc. The next is nitrogen cycle. Now this cycle is very important for us. Now in this cycle, nitrogen is converted into various chemical forms as it circulates in atmosphere, terrestrial and marine systems, mostly atmosphere and biosphere. Now first is the term which you need to learn, fixation. Now what is fixation? During cycles, other than water, remember the element under study get fixed, get stored, assimilated in the body of organism in form of nutrients, and this is called fixation. Like in our own body, nitrogen is fixed in form of nucleic acids, in form of proteins and many other components. Now the conversion of nitrogen involve various biological and physical process, and some of these processes are fixation, ammonification, nitrification and denitrification. The nitrogen in the atmosphere is fixed into nitrogen salts in the soil by various nitrogen fixing bacteria present in root nodules of leguminous plants and also during lightning. Now these salts are taken by plants and used to make proteins. The animals eat plants and this way they get the supply of proteins for their survival. When plants and animals die, bacteria convert the proteins into compounds called nitrates and nitrites. There are other bacteria which convert these compounds back into nitrogen, which reaches the atmosphere. Now this nitrogen starts from atmosphere, ends at it, so this way the atmosphere acts as a reserve for nitrogen. Now nitrogen fixation, it is the process by which nitrogen in the atmosphere is converted into ammonia or other molecules available to living organisms. Now this fixation is required for all life forms, as the inorganic nitrogen compounds are only form in which we can absorb nitrogen. We cannot absorb it from atmosphere. We need it as nitrates. Therefore, as a part of this cycle, it is very important for agriculture and is also used in making fertilizers. It is responsible to manufacture all chemical compounds that contain nitrogen, which include explosives, pharmacological substances, dyes, etc. Now, this fixation is also carried in soil by free living bacteria like Azobacter. Some bacteria which cause fixation are present in roots of leguminous plants or legumes like Rhizobium. Now, it also occurs in air by means of lightning. Now, these are certain diagrams, certain figures which show the bacteria that cause fixation. There is Rhizobium and there is Azobacter. Next step is ammonification. Now, in this step, the organic nitrogen from plant and animal remains or waste turns back into ammonium salts, and it is called ammonification or mineralization. This also involves bacteria and fungus which convert organic nitrogen within remains into ammonium compounds, and this involves bacteria, especially Actinomycetes and Bacillus subtilis, although many other are also involved. When a plant or animal dies or it expels waste. The initial form of nitrogen is organic, that is obtained from life form. Next step is nitrification. It is the biological oxidation of ammonia or ammonium to nitrite, followed by oxidation of nitrite to nitrate, or simply ammonia or ammonium is finally converted into nitrates. Nitrification is an aerobic process that requires oxygen and is performed by a small group of autotrophic bacteria including Nitrosomonas and Nitrobacter. Next is denitrification. In denitrification, it involves reduction of nitrates back into nitrogen gas and thus completing the nitrogen cycle. Nitrogen is taken from atmosphere and given back to it. It is performed by bacterial species like Pseudomonas, Clostridium, and require anaerobic conditions. This is a flow chart which shows nitrogen cycle. Nitrogen from atmosphere change into proteins present in plants, microbes, or convert to ammonia by industries. This ammonia changed to nitrites, which is changed to nitrates. Now, nitrates are absorbed by the plants, animals. Also, nitrogen is converted to nitrates by lightning. Now, proteins which are present in animal plant body, they return back to the resource, that is atmosphere, after death using various pathways. Now, next cycle is carbon cycle. In carbon cycle, it involves the exchange of carbon among biosphere, pedosphere, that is soil, geosphere, hydrosphere, and atmosphere. Now, carbon is in the form of carbon dioxide in air, which is used by plants to prepare glucose, and the process we all know is called photosynthesis. Now, glucose is used to provide energy and convert into other organic compounds. When animals eat plants, these compounds enter the body of animals. During respiration, the energy and carbon dioxide are produced by us, and this carbon dioxide thus is returned back to atmosphere. There is one more process, that is combustion of fuels like coal, petroleum, which add carbon dioxide to the atmosphere. Organic compounds in plants, animals are also converted into carbonates, limestone, coal, petroleum, the shells of animals like snails, in which carbon is fixed. Remember, carbon is a very important component of biological molecules like carbohydrates, fats, proteins. The global carbon cycle is divided into 4 main reservoirs. In nitrogen there was only one. Here we have 4 different reservoirs: atmosphere, biosphere, oceans, and sediments, including fossil fuels. Now, these reservoirs are connected by the pathways steps involved in carbon cycle, which involve exchange of energy and matter. In the earth interior, carbon is formed, is present as mantle and crust. Now, this is the diagram to show carbon cycle. We can all see the process like respiration, evaporation, combustion, photosynthesis, etc., which are involved in carbon cycle. This is one more cycle that shows the involvement of organic life forms, plants, animals in carbon cycle. Now, oxygen cycle. In this cycle, oxygen is moved within the three main reservoirs: atmosphere, biosphere and lithosphere. Oxygen atmosphere is used for respiration, combustion and formation of oxide of elements. Oxygen is sent back into atmosphere by photosynthesis from plants. Now, main driving factor for this cycle is photosynthesis, which is responsible for the modern Earth's atmosphere in which we all live, and it is the integral part of various molecules like carbohydrate, fats, etc. This diagram shows the oxygen cycle. How is it gained by plants in respiration and also the animals? Remember, plants and animals both respire. Plants, they intake oxygen, release CO2, but the degree of this process is so less that the formation of oxygen by photosynthesis surpasses the level of CO2 produced by plants. So net result is the formation of oxygen majorly by plants. The oxygen is assimilated in biomass in form of bones, muscles, proteins, carbohydrates, etc. And it involves the three reservoirs: water, we have the human life and soil. Now, the greenhouse effect. Now, this is a very important phenomena we observe nowadays. In this phenomena, the atmosphere of our planet, that is Earth, traps the radiation coming from sun. And this is the phenomena which cause the warmth we observe in atmosphere. Now, when the sun's energy reaches the Earth atmosphere, some of it is reflected back to space and rest is absorbed and re-radiated by greenhouse gases. These radiation warms the planet's surface to a temperature above which it would be without its atmosphere. Now, gases like carbon dioxide, methane, chlorofluorocarbons, they trap the heat radiated by the Earth, and thus they are called greenhouse gases. Remember, carbon dioxide is always the major contributor for this effect. Now, because of the increase in the greenhouse gases nowadays in our atmosphere, we are seeing lot of changes in our climate. Like the global temperature is increasing. There is an increase in global temperature which is due to excessive greenhouse effect, and we call it global warming. Now, this global warming is causing the melting of polar ice caps, causing all the floods, all the droughts, by disturbing other biogeochemical cycles which run in our ecosystem. The last topic here is ozone layer. Now, this ozone layer is the region of Earth's stratosphere that absorbs most of the sun's ultraviolet radiation. It contains ozone gas in very high percentage, and it is located between the 15 km to 35 km region in the atmosphere away from above the Earth's surface. Now, because of this ozone layer, it do not allows the ultraviolet rays to reach the surface of Earth. As a result, we all are protected from them. Nowadays, what we are observing are ozone holes. These are certain regions in the ozone layer where the percentage of ozone decreases in the atmosphere, and as a result, the UV rays are able to reach the Earth's surface, causing damage to various life forms. Now, ozone hole is a region of marked thinning of ozone layer in high altitudes, chiefly during winter when it is observed. Now, a thinning ozone layer leads to number of serious health risks like skin disease, cancer, cataract. All these UV rays, they reduce the level of planktons in the oceans, and which in turn reduces the number of fishes. It also adversely affects the plant growth, the human life form, and all the animal forms which we observe. Now what is the basic cause of it? The basic cause for ozone hole is chlorofluorocarbons, which are produced by refrigerators, ACs, which we use. Now the ozone hole which occurs on Antarctica in the very early spring is one of the most deteriorating ozone holes we have observed on our Earth, and it is causing a lot of damage to Antarctica and its ecosystem. Thank you and have a nice day.